Go to your thermostat right now, not later. Right now, look at the fan setting. There are two options, auto and on. Which one is yours set to? If you are like most Americans, you either have no idea what those two settings mean, or you assume it does not matter. Some households have been running the fan on for years because someone told them it kept the air cooler and more even. Others never touched the setting at all. It was on something when the system was installed, and it has quietly sat there ever since, adding to every single summer electricity bill without anyone questioning it. The National Energy Assistance Directors Association projects the average electricity cost to cool American homes between June and September 2026 will reach $778. That is 61 higher than last year, and nearly 37% more than Americans were paying to cool their homes in 2020. PubMed Central. According to AccuWeather's summer 2026 forecast, almost no area of the contiguous United States is expected to see temperatures below the historical average this season. The widespread heat will drive up energy demand and could lead to higher electric bills across the country, from the Northwest to the Mid-Atlantic to the Southeast. Texas Controller. This summer is going to cost more than last summer, and if your fan is set to on, it is going to cost significantly more than it needs to. Hidden Systems explains the everyday things in American homes that cost real money, while staying completely invisible on your bill. Here is what most people think when they hear that two options exist on a thermostat fan setting. The on setting keeps the air moving all the time. That sounds like it should be helping. Constant circulation means every room feels the same temperature. The air never goes stale. The filter is working continuously to clean dust and allergens out of the air. For anyone with allergies or pets, that sounds like an obvious advantage. And here is the part that makes this genuinely confusing: none of those things are completely wrong. Constant air movement does reduce the temperature difference between rooms. More air flowing through the filter does mean the filter catches more particles over time. These are real effects. The on setting is not broken. It is not malfunctioning. The problem is that it is doing something else at the same time that costs far more than those benefits are worth. And that something else is connected to the original reason air conditioning was invented in the first place, which has almost nothing to do with cooling air. In 1902, a young engineer named Willis Carrier was hired to solve a problem at the Sackett and Wilhelms Lithography Company in Brooklyn, New York. The problem was not that the building was too hot. The problem was that paper was absorbing moisture from the humid summer air inside the plant, expanding slightly as it did, and causing the ink alignment to shift between printing passes. Images were blurring. Color registration was failing. The plant was losing money on reprints. Carrier's solution passed the warm, humid air over coils filled with cold water. Moisture from the air condensed on the cold coils and drained away. The air that came out the other side was drier. It also happened to be cooler, but that was a secondary effect. The patent Carrier filed in 1906 was titled Apparatus for Treating Air. Not cooling air, treating air, removing what did not belong in it. The technology that Americans now spend nearly $800 per household every summer to run was designed first and foremost to remove water from the air. Cooling was the byproduct. This matters because your AC system still does both jobs simultaneously every time the compressor runs. It cools the air, and it removes humidity from the air, and the on fan setting interferes directly with the second job. Here is the mechanism that most people have never been told. When the compressor runs, refrigerant flows through the evaporator coil inside your air handler. Warm air from the house passes over that cold coil. Two things happen. The air loses heat, it gets cooler, and the moisture in the air condenses on the cold coil surface, it gets drier. The cooled, drier air goes back into your home through the vents. The condensed moisture drips off the coil into a drain pan and exits through the condensate drain line. This is the full cooling cycle. Temperature reduction plus moisture removal, both together. Now here is what happens with the fan set to on. The compressor finishes a cooling cycle and shuts off. The refrigerant stops flowing. The evaporator coil, which was very cold a moment ago, begins warming back up toward room temperature. In auto mode, the fan stops when the compressor stops. The coil sits still. The moisture condensed on its surface continues dripping into the drain pan. It exits the house. In on mode, the fan keeps running even though the compressor has stopped. Air keeps moving across the evaporator coil, but now the coil is warming up. And as it warms, some of the moisture that condensed on it starts evaporating back off the surface and gets pushed back into the airstream and returns to your home through the same vents that just delivered cool, dry air. The system worked for several minutes to pull humidity out of your home. Then the fan pushed some of it right back. This cycle repeats every single time the compressor finishes a cycle and the fan keeps running. In summer, compressor might cycle on and off 8 to 12 times per hour during peak afternoon heat. That is 8 to 12 opportunities per hour for the on setting to return moisture to your home that the system just worked to remove. The consequence of elevated indoor humidity is not just comfort. It changes how hot the air feels. Your body cools itself through perspiration. That process depends on the surrounding air being dry enough to accept moisture from your skin through evaporation. When the air is humid, evaporation slows. You feel warmer than the thermometer says you should be. A home at 75 degrees Fahrenheit with 40% relative humidity feels comfortable. The same home at 75 degrees with 60% relative humidity feels noticeably warmer and sticky. Same temperature reading. Significantly different experience. When the on setting returns humidity to the home between compressor cycles, the indoor humidity climbs slightly higher than it would under auto mode. The air feels warmer than the thermostat reading. The natural response for most people is to lower the thermostat setting. The compressor now has to run more frequently and for longer cycles to bring the home to the lower target temperature. This is where the cost compounds. The fan running extra hours costs money, but the compressor running extra cycles because the house feels warmer than it should costs significantly more. The compressor is the most energy-intensive component in any central air conditioning system. And in on mode, it is being asked to do more work than it would in auto, not because it needs to, but because the humidity the system removed was partially returned between cycles. Here is where the numbers become concrete. A standard central AC blower fan motor uses approximately 500 watts when running. Run it continuously for 24 hours, and that is 12 kilowatt hours of electricity for the fan alone. Residential electricity prices across the United States averaged 17 cents per kilowatt hour in 2025 and are projected to reach 17.6 cents per kilowatt hour in 2026, according to the US Energy Information Administration's Short-Term Energy Outlook. Wikipedia. At 17.6 cents per kilowatt hour, running a 500-watt fan continuously for 30 days costs approximately $63 per month. In auto mode, assuming the fan runs only during active compressor cycles, typically 8 to 12 hours of actual runtime per day during summer, that same fan costs approximately $26 per month. That difference is $37 per month on fan energy alone, over a full summer running from May through September. That is $185 in fan costs, before counting the additional compressor costs that come from the house feeling warmer than it should because humidity is being returned between cycles, before counting the wear on the compressor from running more cycles over the course of a summer, before counting that this has likely been happening in your home for multiple summers in a row. 1 in 6 American households are currently behind on energy bills, with total utility debt expected to reach approximately $23 billion by end of year, according to NEADA. That number represents households where the electricity bill has become a genuine financial burden. Some portion of that burden is coming from a fan setting nobody changed, on a thermostat nobody checked. PubMed Central. Here is the part that changes how most people look at their thermostat. The setting that is causing this was almost certainly chosen by someone other than you. The HVAC technician who installed the system, the previous owner of the house, a family member who heard that on was better for air quality and flipped it years ago. The default setting from when the thermostat was programmed during installation. HVAC professionals are consistent on this point. In summer, in a cooling system, in any climate where humidity is a factor, auto is the correct setting. The compressor cycles frequently enough during hot months that air circulation happens naturally during active cooling periods. The humidity removal that happens between cycles in auto mode, which cannot happen in on mode, is worth more in comfort and efficiency than the marginal benefit of continuous air movement. A ceiling fan in the room you are using addresses the circulation concern directly. At a fraction of the energy cost, a ceiling fan uses between 15 and 75 watts depending on its size and speed. The central AC blower uses 500 watts. Same effect in the occupied room, 1/30th the energy draw. And unlike the central fan running on, the ceiling fan does not interfere with the dehumidification cycle. AccuWeather's summer 2026 forecast is specifically noting a late surge of heat and higher humidity across the Northeast, with above-average 90-degree days projected across Boston, New York, Philadelphia, and Chicago. Higher humidity is the specific condition under which the on-setting does the most damage to your home's comfort and your electricity bill simultaneously. Texas controller. There is one legitimate use case for the on-setting, and it is worth knowing. In winter, when a forced air heating system is running, continuous fan operation helps distribute heat more evenly through the home. Warm air rises. Without consistent fan circulation in heating season, heat pools near the ceiling and in upper floors while lower areas stay cooler. The on-setting has a genuine engineering purpose in that specific context. Heating season, forced air, multi-story home, temperature distribution problem. In summer, in a cooling and dehumidifying system, in any climate where outdoor humidity is above 40%. Auto wins on every measure that matters: energy cost, humidity control, comfort level, and compressor lifespan. If you live in a dry climate, parts of Arizona, Nevada, New Mexico, or the high desert regions of the Mountain West, where outdoor humidity regularly stays very low, the humidity return problem is less significant because the air entering the coil between cycles is already quite dry. In those specific locations, the on-setting circulation benefit and the humidity penalty roughly cancel out. But for the majority of Americans in the South, the Southeast, the Midwest, the Mid-Atlantic, and the Northeast, where summer humidity is the defining factor in how hot the air feels, auto mode is not a suggestion. It is the setting the system was designed to operate on. Here is what to do today. It takes 4 seconds. Go to the thermostat. Find the fan setting. If it says on, move it to auto. That is the complete action. No tools, no service call, no new equipment purchased, no appointment scheduled. 4 seconds and the system begins operating the way it was designed to from the first cooling cycle. Over the next few days, pay attention to how the air feels. Most households notice the air feels slightly drier and more comfortable at the same thermostat setting within 24 to 48 hours of switching to auto. Some people lower their expectations and find they can raise the thermostat 1 or 2 degrees and maintain the same comfort level, because the humidity in the air is lower and the cooling effect of evaporation from their skin is more effective. If the temperature feels uneven between rooms after switching, add a ceiling fan in the room you are in during the day. Run it on a low or medium setting while you are in the room. Turn it off when you leave. Ceiling fans cool people, not rooms. A fan running in an empty room wastes electricity without benefit. Check the air filter while you are at it. A filter that has been running on continuous airflow collects debris faster than one cycling with the compressor. If the filter looks gray and loaded with dust, it is restricting airflow and making the compressor work harder than necessary. A clean filter and an auto fan setting together represent the two lowest cost, highest impact changes most American households can make to their central AC system before summer peaks. Americans are projected to spend an average of $778 cooling their homes this summer. That is a 37% increase from what the same cooling cost in 2020, just 6 years ago. The summer is going to be expensive. That part is settled. PubMed Central. What is not settled is whether your thermostat's fan setting is adding $185 to that bill unnecessarily. Whether it has been doing so for multiple summers. Whether the person who set it to on ever knew what on actually meant for the system's ability to remove humidity. 4 seconds to check. 1 switch to move. Every cooling cycle from now until October working the way it was designed to work. So go look right now and come back to tell me what yours was set to, and how long it has been sitting that way without anyone in your home noticing. Drop it in the comments. I read every single one. The answers are always more interesting than people expect.